Hello. Today I would like to talk about coordinate systems in Revit, what you need geocoordinates for, and where the problem lies. In Revit, objects are usually represented by their coordinates. Here, for example, we have a wall. The wall's starting and end points of the wall are stored as coordinates. For this purpose, the coordinates are saved in the project relative to the origin of an internal coordinate system. What happens if the origin of the coordinates is very far away? Then huge numbers are created here. Revit cannot represent so many digits. This means that the digits shown here in gray are set to 0. The result is that this wall would have a length of 0. That is a problem. This is why you should never construct anything very far away, 10 miles from the origin. How do you deal with large geocoordinates? Revit has a concept for this. It is the survey coordinate system, or the shared coordinates. But why do you often have to work with large coordinates? The reason is that the data come into the project from different sources, e.g., point clouds, IFC files, or DWGs. The survey coordinates form the common reference system. Let's zoom in on a demo factory in Rotterdam, in world coordinates. This is what it looks like on Google Earth. Now let's look at the whole thing in Revit. Here we have a similar view of the scene. Even the same truck is still here. I've prepared something. Here I've constructed a few walls into it and created coordinate labels. These coordinates point to the same wall corner and initially have the same value because the origins of all coordinate systems are in the same place. I'll move them away. Now I have the project coordinate system here. The numbers at the top change. The numbers at the bottom stay the same or the other way around. Here is the survey coordinate system. If I move it, only the coordinates specified in the survey coordinates will change, whereas the project coordinates remain unchanged because the reference point has not changed. I switch to the top view and move the surveyor coordinate system far away. In practice, the origin will be very far away. Now I switch back to the 3D view and see that we now see large numbers here. But in project coordinates, these are the coordinates with which Revit calculates, the numerical values remain the same and sufficiently small. Now it would be practical to also see this symbol in the area of my project. To do this, I switch off the paperclip. If the paperclip is crossed out, I can move the symbol without changing the coordinate origin. I can recognize this by the fact that the numbers on the symbol change. I bring the survey symbol back into the vicinity of my project. As a rule, I place the symbol on a boundary stone or another geodetically known coordinate. Let me summarize. The internal coordinate origin is never changed. It is here. I can't model more than 10 miles away from it and insert Revit objects. This is the project coordinate system. I move its origin to where it seems appropriate for my project. This is the survey coordinate system. I rotated it because true north is generally not in the direction of one of the main axes of the building. In another video, we will show how to be very precise with georeferenced point clouds in Revit and Recap. Thank you very much.